Hi Year 6 and welcome to your last maths lesson of the week. So well done for getting through all of this so far. I have been really impressed with all of the work that you've handed in, so keep going. So we have looked at area and perimeter of rectangles and squares, and we have looked at a bit of a problem solving lesson to do with them as well. So today we are stepping forward and we're going to have a go at working out the area of a parallelogram. Okay, so a little bit different. You might not have done this before, but it's not that hard. Once you understand what a parallelogram is and how we work it out, it's really not that tricky. Okay, we will also be carrying this on next week as well. So let's get started. Rewind then for a bit of our fluency first. What is the area of this shape? Pause the video and give it a go. Nice and easy then to start us off for our rewind. Area, we need the width, we need the length, and we times. So we would just do 9 times 5, which is 45, and the units are centimetres squared, because centimetres times centimetres, centimetres squared. Easy peasy. Okay. Right. Oh, no. I didn't see that. I've got my little screen up. Right. Question then. What does parallel mean? And you've just had a bit of a clue if you could see those pictures. Okay. So what does parallel mean? If I said something is parallel to something else, what do I mean? Okay. So when I say that something is parallel, they are two lines that never meet. Okay, so if you look at these train tracks over here, those train tracks will keep running like this and they won't ever meet, because if they met, the train would then have to fall off the tracks because it wouldn't have the wheels in the right place. Okay, so parallel, something that's parallel like train tracks, they don't meet. Same as most roads, their lines are parallel because they don't suddenly go like this, because then there wouldn't be a road for the cars to drive on. So when we're talking about parallel lines, they are two lines that do not meet. Okay, say it with me. Parallel lines are lines that do not meet. Okay, you might have to write that down into your jotter. So write today's date. You can write the what if you want to, if you really want to do it properly. And then what does parallel mean? It's two lines that do not meet. Okay, and down here, this is a parallelogram. Okay, so we are looking at the area of a parallelogram. This here is a parallelogram. Why do you think that this is called a parallelogram? Well, hopefully you can see that parallelogram has got two sets of parallel sides. This length and this length are parallel to each other. And then these sides here are also parallel because they do not meet. So a parallelogram is a quadrilateral, because quad means 4. It's got 4 sides, like a quad bike has 4 wheels. You have quadruplets, you have 4 babies at the same time. So a quadrilateral with 2 sets of parallel sides is a parallelogram. Okay, so I hear you say, but there are other shapes that are also have 2 sets of parallel sides. Well, have a look at this then. Convince me, do you think my poster is correct or not? So my poster is saying that all of these shapes on here are quadrilaterals, 4 sides, 4 angles. It then says that in the parallelogram club, you have to have 2 pairs of parallel sides. And in the parallelogram club is also the rectangle club. And in the rectangle club, you must have 4 right angles. And in the rectangle club, there is also a square. And another type of parallelogram in the parallelogram club is also the rhombus, which must have 4 equal sides. And in that club is also a square. Right, I know it looks a bit confusing, but have a think. Do you think this is correct? Is a square a type of rhombus, a type of rectangle, and a type of parallelogram? Is a rhombus also a parallelogram? Is a rectangle also a parallelogram? Have a think. Okay, so this might look a little bit confusing on the face of it, but the answer is yes. Okay, so when we are talking about parallelograms for the purpose of this lesson, I am talking about parallelograms, which is like a rectangle that's been pushed over to one side. Okay, but if you're being really picky, a rectangle is also a type of parallelogram because it has two sets of parallel sides. A square is also a type of parallelogram because it has got 2 sets of parallel sides. Okay, and a rhombus is like a parallelogram, apart from all the lengths are equal. So that's like a square that's kind of been pushed over. Okay, so hopefully that made sense. So a parallelogram is a 4-sided shape where it's got 2 sets of parallel sides. Okay, and a rectangle also counts as a parallelogram and as a square and as a rhombus. Okay, just a bit of extra information there for you, because I know some of you would have been saying that just makes sense because a square has parallel sides as well. So hopefully that makes a little bit more sense. Okay, but it's the parallelogram that we are looking at today. We're looking at like a traditional, like a regular parallelogram. Okay, here is our discover them. So we have got 2 children and they seem to be at school today. We've got Alex and we have got Richard, and they are looking at this floor. Okay, now for some reason, and I'm not really sure why, but they want to find the area of one tile. Obviously, that's just what they felt like talking about at break time. So they want to work out what is the area of one of these tiles. And if we look at these tiles, they are parallelogram shaped. Okay. Here is another diagram for us here, which I'll zoom into in a moment so you can see a little bit better. So they've measured these parallelograms. They've measured that the length is 30 centimetres. They've measured that this side here is 25 centimetres, and they've measured from the top to the bottom, which we call the perpendicular height, because since it's perpendicular, it meets at a right angle. You want to write that one down as well. Okay, so is perpendicular. It is at a right angle. So when 2 lines meet at a right angle. Okay, so the perpendicular height is from the top of the parallelogram to the bottom, and that is 20 centimetres. So guys, they've measured 3 different things for us. Interesting. I wonder if we'll need them all. So, what are their names? Richard. So Richard is saying that the way he would find the area of this tile is he would kind of chop part of the parallelogram off, and you can see the diagram at the bottom. He would then move it to the other side of the parallelogram and change the parallelogram into a rectangle. Then he would just find the area of a rectangle. Okay, so if you can, and you have the equipment at home, you can have a go at drawing this out, cut it out, and then I'll go through it with you the next little bit. Okay, so have a go if you can. If you can't, or you just watch me on the video. Have a go at, so basically you take a rectangle. I did this earlier, I should have waited for you guys, shouldn't I? Another piece of paper. So if you take a rectangle, draw a line with a ruler to make it a parallelogram, and then cut it, and then hopefully yours will look a little bit like mine. So I'll put it on, I'm going to try now and change camera so that you can see what I'm doing. Okay, so give me a second and I'll try and get it sorted. So while you're waiting for me, have a go if you can at drawing a parallelogram, cut it out, and then I'll carry on with you in a moment. Okay, I am back. Hopefully you can now see this pink parallelogram in front of me. So if you wanted to make your own parallelogram, just take a piece of A4 paper and then with a ruler, just draw a line from top to bottom like this, and then keep that same angle to draw another line like this, and then cut these 2 bits off, and voila, it's just like I'm on Blue Peter. You should then have a parallelogram that looks a bit like this. Okay, so hopefully you can see this as well as you can see the slides on the board. So I'm going to label this the same as it is on the board. So on their tiles, the length of it here was 30 centimetres. This side here was 25 centimetres, and they've also labelled the something else height. Can you remember what that height was called? Begins with a P, perpendicular, okay? And perpendicular means when 2 lines meet at a right angle. And hopefully you can see there, I'll see if I can make bigger now. I've got the information. There you go. So hopefully you can see that this line going down here is like the height of the parallelogram, and it was 20 centimetres, and it meets here at a right angle, and here it also meets at a right angle. Okay, so here is my parallelogram. So here are my scissors, because the child in the Discover problem said that if we cut down the perpendicular line, if we turned it into a triangle, that's not very neat cutting, Mrs. O'Riordan. Oh dear, I do apologise, that's because I can't see because the camera's in the way. So if we take this triangle, which was here, we'll pick it up, and spin it round, and we put it, oh gosh, I can't really fit that, and we put it over here. We've then got a different shape. What shape have we got now? So it's gone from a parallelogram. I've taken this bit and I've moved it over here. What shape have we got now? Well, hopefully you can see that now we've got a quadrilateral with 4 sides, and this time it is a rectangle. It looks like a square, but it's that's just because I've not measured it. Mine's not perfectly to scale, okay? But so it is a rectangle because this length is 30 and this length is 20. So we have now got a rectangle. Right. How do you work out the area of a rectangle? Well, we take the width, we take the length, and we times. So we need to do 20 times 30. Well, what's 2 times 3? 6. So what's 20 times 3? 60 centimetres squared. So what's 20 times 30? 600 centimetres squared. So the area of this parallelogram is 600 centimetres squared. Okay? Because you've changed it, it is still the parallelogram look, and we've taken part of it and we've moved it over here. Now, let's put it back in its original form. Which numbers did I use to get my answer? So which numbers did we use? Because we had 3 measurements of this parallelogram. We had the kind of the diagonal length, we had the perpendicular height, and we had the kind of the base length as well. And we didn't times 3 numbers together. So which ones did we times? Well, we times the base length, and we then multiplied it with the perpendicular height, okay, where they meet at a right angle. And the reason for this is if you then move this triangle over here, which dimensions make the rectangle? Well, the perpendicular height, which meets at a right angle, with the base, okay? So when you get a parallelogram question to work out the area, you want to turn it into a rectangle, and you want to use the perpendicular height and the base, multiply them together to find the area. This measurement over here, the one that tells you the length of this diagonal, this is like a red herring. Okay? It's trying to trick you. So we don't want to use that. We want to use the measurements that make it into a rectangle. Okay, right. I'm going to pause the video, pause the recording, and I'm going to magically create another parallelogram, and then we're going to have a go at that one. Okay, so stay there, and voila. Hopefully for you that was instant, and you can now see I now have another parallelogram in front of me. I know it's a parallelogram because it's got 2 sets of parallel sides, and it doesn't have a right angle with a parallelogram. Okay, so let's have our measurements then. I'll try and make this one a little bit more accurate. So it is, oh, then again, that's going to be a little bit mean numbers wise. We'll round it. So this is 20 centimetres long. This is 10 centimetres long. And then I need to measure the perpendicular height. So I need to measure from the top to the bottom. I'll draw a line in as well so you can see it. And it's where it meets the base at a right angle, at 90-degree angle there. And that would be 8. Okay, so most parallelogram questions that you get will have 3 measurements. They'll have the base, the diagonal, and the perpendicular height. For some reason that's made that less. There we go. Okay. Some of you might already be able to tell me which measurements I'm going to use, but let's prove it. So what I want to do is I want to turn this parallelogram into a square or a rectangle because I know how to work out the area of that. So I'm going to take this this part here, and I'm going to take this triangle, I'm going to put it here. So now, hopefully you can see that I have got a rectangle. Okay, so I'll show that again. So I've taken this part of the parallelogram and I've moved it over here. For some reason this paper keeps flicking up. So now I've got a rectangle. Right, if this was the problem that I gave you, how would you be able to work out the area? What would you use? Well, hopefully you are telling me you would use the 20 centimetres and the 8 centimetres, and you would times those together. So 2 times 8 is 16 centimetres squared, but I've got 20 times 8, which would be 160 centimetres squared. So which was the measurement I needed to ignore? It was this one here, the diagonal. Okay, so we ignore that 10 centimetre, which was the diagonal. So if I put these back, can you see that you are trying to find the perpendicular height and the base, and they meet at a right angle, and then we times. Okay, I'm just going to share the screen again so that you can see that on here. Okay, so every time, and you might want to write this down somewhere, every time you have got the area of a parallelogram, you want to find the base, the length of the base, and you want to find the perpendicular height, which is one that meets it at a right angle, and then you times. Okay, right, well done. Let's keep going. Right then, let's have a go at this thing together. So I want you to have a go at finding the area of each of these parallelograms. So remember, to find out the area, we need perpendicular height, which meets the base at a right angle, and then we times. Don't get tricked by the other measurements that are there as well. Pause the video and have a go. Right then, let's go through this. So if we look in at A, A is nice and easy because they've only given you 2 measurements. So here is the base, here is the perpendicular height, and I know that because they've helpfully told me that they meet at a right angle. So I need to do 4 times 5, which is 20. What would my units be? Centimetres squared, because it's centimetres times centimetres, 2 dimensions. Yeah. Right, let's have a look at C then. C, a little bit trickier because they've given you 3 measurements, but I think we can work this one out. So we need the lines that meet at a right angle. So here's the right angle. So that tells me that this one then is the parallel height, the perpendicular height. Oh, it's not, I don't know the length of this length here though. And they're the ones where they meet. Ah, wait a minute though. We know that the parallel lines are equal, so we know that this length is equal to this length. So if this length is 7 millimeters, this length is also 7 millimeters. So here is this one's the base. This one, they've just rotated the shape a little bit, so you might tilt your head. Obviously, normally if you had it printed, you would move it. So this one then is my base. Here is my perpendicular height. So I would do 6 times 7, which is 42 millimeters squared. Okay, hopefully it's starting to make a little bit more sense. Okay, so the trick is you've got to find the 2 lines that meet at a right angle. You've got to find that perpendicular height. Okay, we will have a go at B. D is a bit of a challenge, but I think you can give it a good go. So pause the video, off we go. Right, okay then, hopefully you've had a go at that. So remember, you need the 2 that meet at a right angle, okay? And these ones, I've tried to trick you a little bit, but I think we can do it. So here is my base. My base height is 8 centimetres. Which measurement then, and this one that's 6 centimetres, or this one's 5 centimetres, which one would meet 8 centimetres at a right angle? Well, if we carried this over here, or if we took this 5 centimetre line and we moved it, hopefully you can see that this measurement here, the 5 centimetres, this one and this one, these are the 2 that meet at that right angle. They meet at that 90 degrees. Whereas the 6 centimetres, that meets it at an angle. So that's not the measurement that we're looking for. That's measuring the diagonal. You don't want that. So we would do 8 times 5, which is 40 centimetres squared. Right. D is a little bit tricky, and it's really tricky because you can't just turn the page round, whereas obviously normally I would be saying to you, turn the page round, it's going to make it easier. So I'm going to have a go at rotating it for us, which might need a little bit of resizing for a moment, and then hopefully we'll find it a little bit easier. Right, I'm rotating it, rotating it, and rotating it. Okay. I've done it like this so that then this line here becomes my base. Okay, so this one is my base. And I'm now looking for which line meets it with the perpendicular height. Have a look. What do we think? It's tricky to see, but hopefully you can see that this line here, the 3 meters, this one is the perpendicular height because they meet at that right angle. Right. What's the measurement though of the base? What's the measurement of this line here? Is it 4 meters? No, don't let it trick you. Remember, these two lines are equal. So if this line is 4.2 meters, this line is also 4.2 meters. And look, these ones meet at a right angle as well. So it would be 4.2 times, there we go, times by 3. And a horrible. I know that place value is not right. Remember, we talked about that's almost the easiest way to line it up. So you're used to, you just do like normal column method. So I know the place value is not quite right. So 2 times 3 is 6, and that's 6/10. Don't forget my decimal point. 3 times 4 holes is 12 holes. So it will be 12.6 millimeters squared. Tricky, that one. So well done if you got that right. The thing to remember is you need to find the 2 pairs of measurements where the lines meet at a right angle. Okay? Right then. I'm going to leave it on this question. We'll do 2. We'll do 2 questions. We can do it. Okay. This is the first question I want to have a go at, this, the independent activity bit. So pause the video, have a go at answering this question. Off you go. Then when you've done that, last question for today, can you have a go at answering this one? Pause the video and then I'll go through the answers. Off we go. Okay then, let's go through these answers nice and quick then. So these ones haven't got any measurements, which might have thrown you off a little bit at first, but you can do this. So A has got a base, in fact, let's do the base one so it's easier for you. So 1, 2, 3 centimeters. What would the perpendicular height be? Well, it would be 1, 2, 3, 4 centimeters. That would meet at a right angle. So you would do 3 times 4, which would be 12 centimeters squared. B, the base would be 1, 2, 3, 4, 5, 6 centimeters. And the perpendicular height, so from the top to the bottom, would be 1, 2. So 6 times 2 is 12 centimeters squared. C, your base is 1, 2. Perpendicular height, a bit tricky on this one, but you can still do it because you just got to think it would be what it would be from the top to the bottom. So it would be 1, 2, 3, because if I carried that on, that's where the base would be. So the shape is 3 squares tall, isn't it? So it would be 2 times 3, which is 6 centimeters squared. D then, it's a long base, so D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So D is 12 centimeters on the base. And then what's the perpendicular height? Just 1. So 12 times 1 is 12 centimeters squared. Amazing work if you got those right. Second part of that question then was which one of them is the odd one out? So you might have looked at these and thought that D would be the odd one out, but actually the odd one out was C, because C only had an area of 6 centimeters squared, whereas the others were 12 centimeters squared. So really well done if you got those right. Okay, last question for today then. Let's go through this and then we have finished. So really, really well done. Okay, right. This one then. Bit tricky, again, always easier if you can rotate it, but you can give this a really good go. So for this one, I'm going to turn my head, whichever way around looks the wrong way around on your camera. I'm going to turn my head. This is the base. Okay, so this is the base, which is 12 centimeters. Which one of these measurements, which one of these lines would meet at a right angle? Which one would be perpendicular? It would be this one. So I would do 12 times 10, which is 120 centimeters squared. Next one then, this time, this one's a bit easier. Here is my base. Which measurement's the perpendicular height that meets at a right angle? It would be this one. So you do 13 times 10, which is 130 centimeters squared. Okay then, which way round would it be? Are they the same? Is one more than or is one less than? Well, B is bigger, so your more than sign would go like this. Right, well done. I know that wasn't easy, but hopefully you've given that a good go and we will carry this on next week. Right, well done.